Okay, students, we are continuing with the section. So in this, finding the equations of, that is finding the equations of a line passing through a given point and perpendicular to two given lines. A line has been given, two lines has been given. And you have to find the equation of a line passing through a given point. A point will be given, and perpendicular to two given lines. So for that, an example is given for you. So determine the equations of line passing through the point 1 2 minus 4 and perpendicular to the two lines. So two lines has been given: x minus 8 by 3, y plus 9 by minus 16, z minus 10 by 7, and x minus 15 by 3, y minus 29 by 8, z minus 8 by minus 5. So here sorry here okay here the equations has been given, two lines has been given. So equations of 1 2 minus 4, the point 1 2 minus 4, we have to let the equation of a line passing through that point as x minus y by x minus 1 by a. You have studied about that. So x minus 1 by a, y minus 2 by b, and z plus 4 by c. So a, b, c are direction ratios. And 3 means the equation, the above equation is perpendicular to, above equation of the line is perpendicular to the given two lines. So for by perpendicularity we have studied what is the condition for perpendicularity. So for that, a into 3, a into 3 plus b into minus 16 plus c into 7 is equal to 0. That is first equation. And second equation, that is from the two perpendicular from the two given lines, the perpendicularity condition is applied. Then by solving the two equations, you will get a by 2, b by 3, and c by 4, c by 6. That is, we have x minus 1 by 2, a, b, c has been given, x minus 1 by 2, y minus 2 by 3, z plus 4 by 6. This is the equation of the required line. This is how you have to find the equation of a line passing through a point and perpendicular to two given lines. So this types of equation, this types of problems will be solved like this. And next is another equation, that is another problem, that is a line passing through a point 2 minus 1 3 and is perpendicular to the line. The vector is given, r, vector r, I plus j minus k plus lambda into 2i minus 2j plus k, and r, vector r is 2i minus j minus 3k plus mu into I plus 2j plus 2k. That is the vector form has been given. In the previous question Cartesian form, this question vector form is given. The procedure is given there. You have to obtain the point through which the line passes, that is position vector of vector vector alpha. Here is another name is given, vector alpha. And before that a method is given. Look at that method. A line passing through a point having position vector alpha, vector alpha, and perpendicular to the lines vector r is a1 plus lambda b1, and vector r, another line is vector r is equal to vector a2 plus mu b2, and this is parallel to b1 cross b2. That is also we have studied. So this vector equation r is alpha plus lambda into b1 cross b2. And we have the procedure. After that, first you have to familiar, this is the method. Then identify, first is the equation. You have to obtain the equation of the point passing through the line and identify the vectors parallel to the given line b1 b2. You have to find b1 cross b2, vector b1 cross vector b2, cross product should be find, vector product should be find out, and then the equation of the required line is that. So the solution of the given equation is given, the given question is given there. And next is the coplanar and skew lines. What is coplanar lines and what are skew lines? Okay, the lines which lie in the same plane are coplanar planes. Coplanar lines. That is, you are familiar with collinear lines. Lines means collinear points. Sorry, collinear points. You know, yes, which is in a straight line. The points which is in a straight line. Okay, yes, sorry. Okay, the lines which lie in the same plane, that is coplanar. Okay, in the same plane many lines have been there. That lines which is in the same plane are coplanar lines. Then what is skew lines? Yes, two straight lines which are neither parallel or nor intersect. Okay, which is not parallel, neither parallel nor intersect. That lines are skew lines. Okay, that is, if two lines are intersecting, they are always coplanar. If they intersect, they coplanar lines. But the converse, which need not be, if any coplanar line may not be a intersecting lines. Okay, so two straight lines are coplanar if they are either parallel or intersecting. If it may be parallel, it may be parallel lines or maybe intersecting lines. And two straight lines in a space, okay, in a plane or space, which are neither parallel nor intersecting are skew lines. Okay, then the two skew lines are always non-coplanar. It is not coplanar. It is non-coplanar. Skew lines are non-coplanars. Okay, yes. And next is the condition for intersecting two lines. What is the condition for intersection of two lines? When will two lines intersect, and what is the condition? To find the condition that two given straight lines should intersect, that means they are coplanar. What is the condition? Okay, that is two straight lines. You know the equation for a straight line: x minus x1 by a1, Cartesian equation. It is the Cartesian equation. Yes, x minus x1 by a1, xy is equal to y minus y1 by b1, z minus z1 by c1 equal to some r. And another line is taken: x minus x2 by a2, y minus y2 by b2, z minus z2 by c2 equal to capital R. These are two equations. Okay, and the direction ratios are a, b, c. a1, b1, c1, a2, b2, c2 are direction ratios. Okay, and they are proportional. Okay, and any point on the first line, which is p, that is also we have, what is the coordinate, that is also we have studied in the previous class. So x1 plus a1 r, y1 plus b1 r, z1 plus c1 r, it is the point p. And on the point, and from the second line a point will be, yes, x2 plus a2 r, y2 plus b2 r, z2 plus c2 r. That is the equation where capital R and small r are non-zero real numbers. So first two lines will intersect if they are non-parallel. If and only if they are non-parallel. If it is parallel, it will not intersect. So if it is non-parallel, it will intersect. Okay, that means the direction ratios may not be equal. These direction ratios are not equal, and that if they have a common point, if p and q coincides for some values of r and capital R, small r and capital R. For some small r and capital R, the point p and q coincides at some point for small r and capital R. Okay, that means the first coordinate, yes, the first coordinate and second coordinate will be equal. That means the first two coordinates of the points may be equal, second coordinates of the point and third coordinate of the point. Okay, that is there, and that equation will be simplified. Okay, and yes, determinant, yes, you know what is the property of determinants. By the property of determinants we can say this, and the lines x, from that it is equal to 0. So x2 we can change, yes, can change column and rows. And the lines x1 minus x minus x1 by a1, y minus y1 by b1, and z minus z1 by c1, and x minus x2 by a2 equals y minus y2 by b2 equals z minus z2 by c2 intersect if and only if this determinant is 0 and the ratio, the directional ratios are not equal. So this is the condition for intersecting two lines. Okay, the questions will be find out the given lines are intersecting or not. So you have to find, yes, you have given two lines, you have to find the determinant x2 x1 y2 y1 x2 minus x1 y2 minus y1 z2 minus z1 a1 b1 c1 a2 b2 c2. That determinant equal to 0. You have to find the determinant value. If the determinant value is 0 and the direction ratios are not equal, you can say the lines are intersecting. This is the condition. Okay, yes. Next is example has been given. You have to show that the two lines are not intersecting each other. For first you have to, yes, name that lines, some r, r1, then direction ratios are given. You have to find the direction ratios are equal or not. Yes, first is you have to find out first condition. Then the second is, yes, the next is find the determinant. Okay, yes, that is the question. And questions has been given. You have to show the lines intersects, point of intersection, coplanar, if the lines are coplanar or not. Yes, these are the questions. Yeah. Okay, so this is the last section of this lines. Okay, I think all of you understood. Do this exercises, examples, and also exercise problems. Thank you, students.